Okay, we'll go ahead and get started. Welcome, everyone. Thank you for joining us today for the Tenable Parabolics webinar on shielding your future. Everyone has been muted upon entry, but there is a Q&A function that you can use found at the bottom of your screen to ask any questions, and we will do our best to either address them during the session or at the end of the session. And thanks for joining us today, and I'll go ahead and turn it over to Alex to get us started. Thank you.
Thank you very much, Lindsay, and thank you very much for everybody attending, and as well to our great panel. Nathan, thank you very much for joining us, and Eric, great seeing you here. So, why this is a very important subject right now? I guess one of the things that you can say about any vulnerability management program is that while many of them have been created years ago, they actually work and they impact the organization. And therefore, a lot of organizations are very reluctant to change those programs because they do work. But there are a lot of changes around us in terms of how the modern cyber attacks are conducted, as well as how the perimeter has changed throughout the last few years. And therefore, it is important for us to be able to modernize those vulnerability management programs. And this is why we have Nathan and Eric here with this wonderful webinar. Gentlemen, thank you very much for joining us, and I'm going to turn it over to you.
Nathan, do you want to do a quick introduction?
Yeah, sure. So good morning, good afternoon, everybody. My name is Nathan Wensler. I am the Chief Security Strategist at Tenable. I've been in the information and security field about 26 years now. Most recently, before my time at Tenable, as a CISO at a number of smaller companies and an executive management consultant and vCISO for financial firms. But been working in the vulnerability management and AppSec space here for pretty much my entire career. So very happy to be here and happy to be part of the conversation.
Awesome, thank you. I'm Eric Matthews, CTO at Parabolic Cybersecurity. I think I know a lot of the folks joining us today, but maybe there's some new faces. With that, let's just dive right into talking about this. This is something that I've talked about before. Organizations are aware of this, especially at an enterprise level. That security isn't necessarily as much about that perimeter, the old sort of view of perimeter and on-prem infrastructure. There's still obviously a use for that, and larger organizations are still working with their on-prem infrastructure a lot. But the thrust of the changes in IT have really moved forward and then into a bunch of new areas, and managing vulnerabilities in those areas is a key thing that we have to think about as we move forward to that sort of new space. So, what is the modern enterprise? Obviously, lots of us are facing the legacy infrastructure that we're working with and may continue to work with. But if you fund a startup today, it's unlikely that there's going to be any racks of servers and that the organization is going to have on-prem equipment at all. The real modern enterprise and the shift for larger existing enterprises is toward cloud and distributed processing, distributed DevOps, mobile endpoints, and even application-centric data delivery, as well as IoT or OT devices. When we look at where the source of data and the source of customer interactions with an organization's data, it's shifted into, for example, mobile apps. It's shifted to applications that are hosted in the cloud. And those legacy systems have taken a little bit of a backseat, although they, again, they still exist. But let's go on to the next slide here. The real shift is where the breaches are happening. And when we look at data, and this is data, I think, from Cisco last year, we see where exploits are happening. Obviously, phishing, users have always been a risk. We know that. That's an area that's difficult to manage, but I think every organization's aware of that. But I think it's surprising to a lot of organizations to hear that the exploitation of public-facing applications is the second largest cause of breaches. When you think about it, it may not be surprising because you hear about the breaches of LinkedIn or Ashley Madison or whatever those other breaches have happened. There's been a lot of them, but that's a really significant issue that's overlooked by some organizations and maybe undervalued by others. But there are other areas of breaches that have been exposed. Public data is a big one. And that's part of phishing attacks. So when we look at public data risks, how are your or attacks against users anyway, are your users' credentials being exposed? Are they sharing passwords with their LinkedIn profile that's been breached? And are you exposed to things like typo squatting and targeted attacks from social engineering? Beyond that, there's also the application code. So when we talk about public-facing applications, a lot of those are homegrown applications. When we talk to banks, when we talk to large retailers, when we talk to organizations, insurance companies that are developing their own applications, those are significant risks to the enterprise. And then moving beyond that, IoT, OT, cloud infrastructure, identities, and entitlements have all become a big component of the external attack surface. Nathan, what are you guys seeing at Tenable when we see external attack surface?
Well, I mean, the landscape is kind of evolving and changing quite a lot here as you've got a pretty broad mix of maturity in companies and what they're deploying out into public facing. So, you still see everything from kind of your old school traditional single perimeter firewall and a couple of web applications or website type things, posted publicly, all the way to much like you mentioned here about some early stage startups where their entire infrastructure is public facing, essentially all their services, all their applications, SaaS platforms, virtualization environments for their services or whatever applications they're putting forward. So I think what's most interesting about it is that there really is no standard definition anymore. I mean, 25 years ago, we could talk pretty easily about a public side DMZ internal sort of segregation, but all of those lines are blurring in a lot of ways. And the types of assets that we see on the perimeters are all different now, from your traditional web servers out to those what used to be kind of internal only things, directory services, mail servers, that type of those kinds of functions. So it's really becoming important, I think, for every organization to make sure they kind of take a step back and do a really good job of understanding their particular public facing attack surface, because what you're going to need to defend it, what you're going to need to harden those kinds of systems is going to be completely different than your neighbor or your competitor or someone else in your vertical, just because everyone's sort of implementing and deploying a little bit differently these days. So it's making the game a lot harder, but that's, I mean, unfortunately, that's the reality of what we're doing is everyone's deploying new services, new architectures, new applications.
Great, yeah. And I mean, you can go on to the next slide, but one of the areas that we see organizations still doing and is the testing is a point in time. And that's a real challenge for the enterprise or the small business or the startup is, are we doing a continuous testing or are we doing a point in time once a year, once a quarter, whatever that looks like? Your traditional penetration test with a report, go back and remediate, and then we call it good and we're done, is fine. I mean, it's a good part of a security program, but it's not the whole security program. So vulnerability management becomes the real shift and that continuous testing. Move forward here. So, how do we shift to continuous monitoring of various different types of assets? What are the benefits of that? Typically, we have sort of a limited view of a point in time. That's the sort of old thinking. And how do we, number one, identify vulnerabilities as soon as they come up? If we do a pen test in April and then a vulnerability was introduced in November, we have no idea that that was the case until we've done that test. Obviously, then remediation, especially when it comes to things that are currently in development. For example, you can have an environment that's not live. Is it currently in development? Or you can have an application and the application code that's currently in development. And if we don't know about the vulnerabilities until release day, obviously we have some significant impacts to the production timelines and the costs. So those are all areas that ongoing vulnerability or understanding vulnerabilities in an ongoing way can help, whether it's cloud environments or whether it's application code or external attack surface. Nathan, did you have any feedback on that?
Yeah, absolutely. I think this is, one of those areas where anyone who's running a security program today, and this is true for every aspect of it, needs to really start to understand what the purpose of that security program is. If you go back several years, I think most people would have seen a security program as a very operational kind of IT function in the organization. And that lends itself to this notion of like, I can just do once a year testing. Check the box. Did we do the thing? Yes, no. Did I validate or did we check the environment? Yes, no. That's a very operational kind of transaction. But security is a risk function, right? We're not really an IT function anymore. We're a risk management function. Risk is a constant. We have to be evaluating all the time. You have to look at the landscape of what's going on, what's impacting your organization, what could potentially impact your organization, where are you most at harm, where can you best put up defenses and controls to make sure that you're defending your assets. That kind of constant nature of risk evaluation, risk assessment, which is true in any other risk management field, whether that's finance or legal or anything like that. You're constantly looking for those sort of risk factors. Cybersecurity needs to be in that mode as well. So it's a shift in many ways of perspective. Right? People need to start embracing this idea that your security program really is about constant evaluation, constant decision making around what do I address first, where do I focus my resources, what controls do I put into place. And that yearly testing, as you mentioned, it's still valuable, but that should be used not as necessarily as one of your controls, but as one of your validation points. Right? Is all the work that I've done through the rest of the year, the decisions that we've made to lower risk or to remediate issues, did it work? And that yearly test can be the validation point of, yeah, you did a great job, keep it up, or no, you're not remediating fast enough, or there's still things slipping through the cracks. And you go back and you revisit your processes and workflows again to make sure that you're identifying those risks as quickly as possible. You understand how they can impact your business, and you're remediating those things as fast as you possibly can. Because at the end of the day, the risks and the threats that you're faced with, they're coming at you as fast as they can every day. There's a motivation there by those the attackers to move quickly. So it really does require a change in perspective of how we look at that once a year testing model, which was very kind of IT centric, and how we move into a proper risk focused model, understanding our role for the organization, understanding that this concept of ongoing visibility is really the key to understanding what's going on so you can make those good decisions and start to really manage the risk well. That's got to be the goal for everybody these days.
Yeah, that's a good point. And one of the things that we definitely run into is it's a challenge for organizations to shift out of the idea that, hey, if we do this test, we'll find all of our vulnerabilities like right now, and then we can fix them and then they won't come back. And I think even in application development, we shift, like almost all application development shops are shifting away from waterfall models and into an agile development process. I remember reading that for a while, a tool like Gmail was getting updated code pushed to its production environment 3 times a day, and they can only do that because they're comfortable with their with their DevOps process and the ongoing visibility around that, as well as changes to infrastructure or cloud environments are kind of the same way. It's very difficult to establish gates anymore when you have this distributed environment that allows an organization to sort of take a monolithic testing approach and have a yes/no approval that's signed off by a bunch of people. And what we need to do is start shifting, how we have a risk-aware model for ongoing testing, how we manage those vulnerabilities as they come up, and then executives in audit can still view the process and verify the maturity of that process along the way, without necessarily having these hard gates on a testing, for example. Again, the testing, one point in time testing is usually deeper, it's usually more manual, so there's some value, there's a lot of value to that, but that's an additional piece rather than the sort of sole test gate.
Well, yeah, and I mean, as organizations are moving more to the cloud model for things, you're really building more of a development, or almost like a traditional development style pipeline. I mean, that's what the CI/CD pipeline is, taking code from development, moving it into your DevOps orchestration, moving it out to production. It's the same kind of process flow, but that's now what you do when, traditional IT, you would have had someone building a server OS and then hardening the OS and then building the drive image and then deploying the image out to all the hardware. And it's essentially the same concept, except now instead of OSs and heavy systems, it's applications and code. So those ideas of how we validate, check the code, how we review everything now is exactly like you said. It's got to be focused in code. It's got to be focused in applications. It's as early in the process as possible so that you're catching those vulnerabilities either as they're developed or, if you're like a lot of developers do, grabbing code or libraries from shared resources and public repositories. You got to vet those things as well to make sure you're not introducing new vulnerabilities into the environment. The same would also be true with the orchestration layer, right? One of the more common things that we certainly see is that even with a lot of code testing, which is critical, mistakes happen. It's not even necessarily new vulnerabilities that are discovered in the wild or that criminal actors are coming up with. It's, some architect forgets that, oh, shoot, that repository has the old code and I just re-leverage that library into this package for a container and I deployed it accidentally. And so there's a lot of places where it can go wrong in that process today. And so having that sort of constant evaluation process, having that visibility, again, back to this point, and as early as possible in the process is just absolutely critical to stay on top of this situation as you're taking advantage of these really robust technologies for development, deployment, and all the rest.
Yeah, so up next, we're going to talk about some challenges. So what are the challenges you get from some of the ideas around continuous testing, and how do we address those? Obviously, ongoing testing, bringing up whether it's in code or in infrastructure, you're leveraging automation to a greater degree than, say, a manual pen test or a hand check of a hardening guide or whatever that is. And that does have some challenges that we need to be aware of and make sure that we're addressing in the process. So automated scanning does have a higher false positive rate. That can vary by tool, it can vary by type of environment. It's especially prevalent in automated tooling for like application security. It's less prevalent in tooling for infrastructure security, and so there's a range of false positive rates. But that's a challenge that you have to manage and be aware of. Second, there's the variation in severity ratings. So a lot of times an automated scan is going to give you a canned severity rating based on something immutable like a CVSS base score. And the CVSS base score is a good example of something that you generally try to score something in its worst possible case and imagine what it would be like in environments, but without the contextual ratings of how sensitive is the data and how exposed is the system and things like that, it's difficult to score those. So part of that risk awareness process is making sure that number one, your tools can help you in that way, and number two, that there's some awareness of the different contexts for the severity and the rating of the severity. I know it's a challenge with large enterprise when audit comes in and says, what do you mean you downgraded that high to a low? Please justify it, because then we have to have systems for being able to validate that security. At the same time, I've also seen the projects with large enterprise just saying, make them all low, nobody will ask. And that's a challenge too. So making sure that you've got a good process around that to make sure that the tooling can help you get to the right place is important. Other areas that, these are all things that both Parabellix and Tenable are trying to address in this process, because we both have continuous testing tools. Cohesive tooling for multiple categories of vulnerabilities is an ongoing challenge. I think Tenable's moving, like Tenable One has been moving toward that ongoing. There's sort of bringing all bunch of tools together, and Parabellix has a couple of tools we're working with Tenable to have that sort of single pane of glass view when possible. And then the other challenge that we see is domain expertise for different kinds of scanning. For example, when you have a single pane of glass, if you have a cloud vulnerability versus an infrastructure vulnerability versus an application vulnerability, you have 3 different audiences for your data and your risk. And so contextualizing the risk requires expertise in those different areas. So making sure that you have buy-in, visibility, and participation from the different business units or different areas of expertise in IT to make sure that you can contextualize those vulnerabilities. Having a vulnerability management person trying to contextualize vulnerabilities for an Azure cloud application code and, say, infrastructure testing or attack surface monitoring are going to be challenged to be able to categorize that. So there's an organizational demand for multidisciplinary work when you bring in a multi component vulnerability management concept.
So,
Nathan?
gentlemen,
Or Alex?
I have a question for both of you, given that. So, obviously, tools are extremely important. What about the process? Can we talk a bit about the process of how the modern organization should build the operation and triaging around those findings, given the fact that Tenable is now offering that single pane of glass, and we can integrate with that single pane of glass. But as Eric was talking, there are multiple resources and multiple experts that needed, given the fact that we're now bringing together the application security vulnerabilities, cloud, container. What would that, I would not afraid to call triaging process, should look like for an enterprise in this case?
Nathan, do you want to tackle that?
Well, I mean, I hate to say this, but the simple answer is I don't know. And look, I'm not trying to be flippant, but what I mean by that is it's going to be vastly different organization to organization. That the process part of it, there's no set standard way to do this right. It's going to depend on so many variables. What kind of staff do you have? What kind of expertise do you have on hand? What sort of risk tolerances does the organization have? What sort of support and buy-in do you have from management? So we're talking about political capital and what sort of organizational support is there? What tools do you have available for triaging or for remediation? Is it manual? Is it automated? Can it be automated? Do you have outsourcing help? Do you have? There's so many possibilities, and those factors will drive what the right process is for an organization. At its core, I do think, though, what I was similar to what I was saying a moment ago, is that security teams need to look at this separation of where we do the risk management portion and where we operationalize the work that needs to be done. So some of the triage part is this initial thing here with looking at the results of our assessments, looking at all the different findings, and finding ways to make that easier. There's many things we're probably going to talk about today to talk about how to help make this easier. But the goal is to look at all these findings and make a good decision about what to remediate. What's the thing I should start with? Or what are the 5 things I need to start with? If I can identify that, then the risk assessment piece is essentially done. We're making the determination of what's important to address. Then you've got the operational part of that, which is now that we've identified what the risks are we want to address, how do we solve it? Do we need another tool? Do we need more budget? Do we need more people? Do we already have the people? Do I just need to find the right people? But it's sort of a handoff that goes from identifying what the problem is we want to address to the tactical execution of actually fixing the problem. And that does, to your point, Alex, I mean, it does require a lot of buy-in, especially for larger organizations, that you've got all the various IT teams in place and working with you, that you've got strong collaboration with your cloud team, your network team, your application team, the development group, whoever is going to be involved for remediating a problem within a certain sort of technology category. But that shouldn't necessarily be on the security team to resolve. That's got to be the operational folks who have to go and implement those kinds of fixes. So where those pieces lie is going to be a little bit different for everyone. And how those workflows and processes work going to be a little different for everyone. But fundamentally, making that kind of separation between how we identify what to solve first and then executing on the fix, that's the separation that I need, I want to see in a lot of organizations, so that the operational folks can focus on that, the risk folks can focus on that side. How that handoff happens, how the flow happens, is going to be different for everybody.
And that's an amazing advice, Nathan. And what I want to highlight is that separation between the risk management and the operational stuff. The biggest problem that I see in many enterprises is that handoff never happens smoothly. So this is, if you are a vulnerability manager and you want to improve one thing, just one thing with your vulnerability management program, make sure that you have well-planned, well-structured handoff between the risk management and the operationalization. That's a very important thing. Eric, do you want to add anything?
Yeah, very briefly, but one of the things that we focused on with our tooling at Parabellix is in separating the viewpoints of different organizational participants like that. So we have, for example, in our continuous application security testing platform, we have separated the viewing, the view, the sort of typical view and the reporting for example, frontline developers who can see have a very different requirement set than, say, an auditor or a manager or a product owner. So we have sort of different reporting for those. The developers by default get a very contextualized, trimmed down view of vulnerabilities, where the auditor has a trending view with some high level scorecards, because the auditor doesn't need to see, unless they're checking on the specific things. But the management team, especially, they don't need to see the details of each vulnerability and need to ask questions about why is this more severe than this, or what does this mean. Instead, we have scorecarding with, for example, the OWASP categories as a high-level view of where do we have success and where do we have issues. So that's an interesting view forward. The next slide, I think we already talked about in the process of that conversation, but I'm just going to mention it briefly before we go on to a few other things. A lot of these tools have a lot of vulnerabilities. An example that we have is when we enable a DevSecOps environment, for example, SAST, SCA says, and the other tools involved in analyzing code. It's very common for a code base to have something like 1,000 vulnerabilities on the first day. So managing the overload of that and figuring out how to prioritize those without getting stuck can be a challenge. And that's an area that, you know, our tooling specifically is designed to help with that, especially when you get into DevSecOps. But the first day you turn on a lot of vulnerability management tools, they can be fairly noisy. So that's a challenge to onboard them, but once they're in a steady state, you have a much more stable view of the environments and you get to see the delta. So that's an interesting perspective. I don't know if you wanted to take just a minute on that, Nathan, before we move on to another topic.
Well, I think this is again another good example that kind of supports my case about the whole risk management versus operational separation, right? And if your security program is designed to take that sort of risk management mindset, you introduce a new tool. Yes, tools generate a lot of data, but you look at that data from a risk perspective, the first thing you're going to say is, let's look at the top 10 problems. What are the biggest issues? If you're an operational person, you're going to look at the output and go, oh, I have a list of work to do, right? You're not looking at it from necessarily that prioritization perspective. So it's another one of those places where I find organizations that have told me, like back in my days as a consultant, we can never catch up. Well, why? Well, because the tool gave us 1,000 things to do. We're trying to do all 1,000 things. Well, why are you trying to do 1,000 things? Like that's it's too much. It's not reasonable. Because it's looked at as an IT thing. Well, the tool told me to do 1,000 things. I'm an operational function. I try to do 1,000 things. That's not where we want to live, right? Prioritization in whatever form. And there's many ways to do it, many techniques. There's tools that can automate it for you. There's frameworks that can help you with that. But that prioritization approach is so critical for organizations to be able to get around or to get ahead of the problem. The more you can prioritize, the more you're going to demonstrate better value to your C-suite, to your leadership. You're going to solve more meaningful problems with less effort, less work. Eventually, we want to fix all of the things, but you've got to focus on those first few things now. And even as you introduce new services, new tools, that mindset is going to help you prevent your teams from getting overwhelmed and kind of keep you on track with a focus on how to address the problem in the right way.
Yeah, great feedback. So we're going to take a few minutes and just talk about some of the solutions that we're offering. And this isn't going to be a technical view of our product offerings necessarily, but just a quick overview of how we're tackling some of the challenges with vulnerability management in our various different solutions. One of the things that we at Parabellix sat down to do when we started, and as we've been working with organizations throughout different segments and different sizes, is to really have a security lifecycle where we can offer solutions across the board in different areas of security, and different parts of the process of developing and building and deploying both applications and infrastructure. So this security lifecycle, to be honest, was focused on on software development, but it really does apply to infrastructure. It applies to deployments of other environments, because all of these steps are and should be and are part of the process in developing and deploying infrastructure and applications. On this particular slide, we have outlined the services that we offer. The blue ones are consulting services, and then other areas like continuous penetration testing, which is our flavor of attack surface monitoring, vulnerability management, which we work with Tenable, and what we call our continuous application security testing platform, which is an integrated package to do a DevSecOps environment. So the bottom half of this slide is the continuous application security testing platform with all of the different tools associated with that, and the different services and reports. And then obviously, we can integrate that with the continuous pen testing, vulnerability management. It usually comes with annual penetration testing as well. So that's kind of part of the continuous application security testing, or CAST platform. And so that's all integrated components, integrated services, tools, and methodologies that we work with organizations to implement and to really streamline that whole life cycle process, instead of thinking of infrastructure as an operational object. planning around building that as a process is key here. So if you can go forward, Nathan. One of the things that we talk about, and I pointed this out before, is our CAST platform is taking what we call the MDR model. When a long time ago organizations were looking to do security monitoring, they were buying large SIM devices, which large organizations still do because they can operate a stock and there's value in that. But the smaller the organization or the development unit is, the more difficult it is to, for example, go out and buy a competitor, a Synopsys, you're going to spend $1 million on the tool and then still have to staff a multidisciplinary staff in order to be able to execute that. Smaller organizations, anywhere below the largest enterprise, have shifted away from the SIM and SOC model because they can't functionally operationalize that. It's too expensive and difficult to maintain. Instead, organizations are purchasing solutions like MDR, or Managed Detection and Response, for their network security. But for application security, we wanted to offer the same concept, which is a fully managed platform that handles the tooling, the expertise, vulnerability categorization, prioritization, aggregation, noise reduction, and clear remediation advice, as well as customer-facing or auditor-facing attestation, to be able to give you sort of a whole view of an application security platform. And the idea here is to take the vulnerability overload that you get from code scanning and essentially pull that in with our team's expertise to identify the developers' top 5, for example, for this sprint. We often will break that up by sprint or by month, depending on the customer's needs. But at the same time, an auditor or a manager can see trending and scorecarding. And then everybody sees clear remediation without having to do a ton of research. And then as part of this, we work with organizations to have periodic meetings to be able to sit down in a developer scrum and talk through some of the issues and have the availability to bring that DevSecOps expertise to organizations or even small business units within a large organization. For example, a team that's tasked to independently develop something like an app or something like that, aside from the main IT unit, to be able to bring them a cohesive security tool that they can use without a lot of overhead. The other solution that Parabellix is offering now, we call the continuous penetration testing process. Now, this is a flavor of external attack surface management, and it's something that Tenable offers and a lot of other organizations offer as well. The value that we're bringing here is that, again, our focus at Parabellix is really on not solely using the automated tools, but bringing in a human element to have this essentially be an automated tool, but always validated by an engineer. So we're running this completely as a managed platform that those results are curated. Any vulnerabilities that are discovered are validated in the same way that they would be for a pen test, but in a continuous process throughout the year. A lot of times we talk with customers and say, well, one pen test is great, but 365 is better. So those are 2 areas that we provide services to help the vulnerability overload while enabling continuous testing throughout different kinds of platforms. But when it comes to things like infrastructure and cloud, I hand it off to Tenable to talk about their platforms.
Yeah, thank you. Yeah, Tenable, from our side of it, we're looking at sort of that's becoming that decision-making engine in a lot of ways for risk for organizations. A lot of folks know us for Nessus, which was sort of the original vulnerability scanning tool, which I think in just a week here or so is going to celebrate its 26th birthday. So, we've been at vulnerability management for a long time, trying to help solve the problem for identifying risk in your traditional IT infrastructure assets. But as the technology landscape has grown, as we've moved into other types of technologies, cloud platforms, virtualization platforms, credentials, all these different assets that people are trying to manage, we recognize that we needed to extend that concept out into kind of the whole stack of things. And so we've built a lot of technology, acquired technology in some places to be able to put a lot of tools in the toolbox today to be able to assess technology in an accurate and safe way, whether that's your OT assets, we've got ICS and SCADA systems, all the way out to your cloud infrastructure, your containers, all of the things that you might have in sort of a public cloud platform, and anything in between. We've brought those tools together so you have the capability to continuously assess these things for risk and understand sort of the technical challenges that might be involved there. With that, of course, generates a lot of data. We take that data into our platform where we run a lot of threat intelligence and analysis against it, where we start to do some of that prioritization work for our customers. We have a dedicated research team here at Tenable. I think we're about 200 people now in that group, which all they do is look at what's going on in the landscape publicly, see where challenges are happening. Are criminal groups starting to spin up attacks? Are they leveraging new attacks? Is there new proof of concept code for something out there? And we start to apply that to the findings so that we can not just understand the risk in context, but we can start to normalize the data a little bit and talk about risks in the same way. And that's all really designed to help folks make better decisions about these things, leveraging analysis tools. We've integrated a lot of new data analysis tools on that data for trying to understand where to start. So things like attack path analysis are ways to visualize where risk lives in the organization, no matter what the asset is, and identify the choke points of where you probably should focus first to address a risk or address a problem before before it's exploited or before a breach happens. All of this together is in our platform we call Tenable One. It brings kind of all of these different pieces together, including Nessus. For those of you who are wondering, yes, Nessus is still core and still part of the process for traditional IT. But the goal here really is again to kind of be this decision-making engine, so that on a constant basis you can reevaluate your organization, you can see where you're at most at risk at a given time, and ideally make better decisions around how, when, and where to deal with that risk. And I'll take just a minute just to show a couple of examples of what that looks like. First and foremost is that prioritization piece. Like Eric mentioned, the challenge for a lot of organizations is trying to understand risk in context. And when you have tools that generate lots of different results, whether that's your traditional scanners in CVSS or a DAS scanner doing your OWASP checks that are results in like low, medium, high, what you end up with is, for most organizations, is they get all these findings and they're looking at different sets of findings, but they're left with the question of which one of these things is worse. It's great. I have a missing patch over here that's an 8.2. I've got this SQL injection vulnerability that's a high, and I've got this misconfigured thing in my AWS environment that's a fail. Which one's worse? Well, those numbers aren't related to each other. It's very hard to know that. And really the only way you can know that is if you have expertise across all of these different areas, which not everyone does, and be able to understand the specific business context of the organization, to know what all the assets are, to know how important they are to the business, and start to do all these kinds of sort of manual factorings of trying to determine which one of these things is really the most important. This is why I've said for many years, Microsoft Excel is the most widely used security tool on the planet, because that's usually where we have to do that analysis work to pull these things together and figure out what to do first. One of the ways that we're trying to solve that here at Tenable is through what we call our Vulnerability Priority Rating, or VPR. It's a technical score for risk, but it is again factored through our research team with a number of threat intel sources. We're looking at about 130 or so different metadata points about each finding. And this is not just CVEs. This is those, OWASP top 10s, it's the misconfigurations, it's identity security challenges. Anywhere that we can identify risk, we try to give it a normalized rating of how technically severe is the problem? And that's going to change as we see new information, new threat intel. Those scores are going to change. And so, we look at this just in CVEs, it's about 28 million different data points that we're looking at. We reevaluate this stuff every 8 hours in order to try to give some context to all of those different findings and normalize information. So we gather the data up here first. We've run through this process constantly to do the contextualization. And once we apply that kind of scoring, what you end up with is a situation that looks more like this, where we can talk about each of the risk scores, the VPR score, in a uniform way. We apply something we call asset criticality rating, or ACR. That's really just how important is the asset to your business. That's really it is. If you have something that's sitting in your lab, it's probably a 1. If you've got a domain controller sitting on a perimeter for some reason, that's definitely a 10. That's something that if it goes down, it takes everything down. When you factor those things together, we can output a risk score that's called an exposure score. And that score makes it a lot easier to make decisions around where to start. In this case, that SQL injection vulnerability in the middle, it's a 901. 901 is bigger than 827. That's probably where I want to start. It's a simple, quick, relative way of looking at risk, so that at least we can get to that process of understanding what to fix first faster. Now, this, of course, gives some very basic kind of business contextualization. It gives some very strong technical consideration. But we're taking these concepts of normalizing this data one step further in the sense of that decision-making engine I mentioned where we're looking to be. If you think about what this means, if I can take all of these different findings and normalize them together, I can also start to build connections between them, how one affects the other. Because we can understand the identity landscape, we can understand the cloud infrastructure, we can understand the internal IT infrastructure. We understand how all that's connected. We can start to make some better decisions around even these individual technical problems where we should start. Give you kind of an example of what that looks like. We could start with a laptop in our room, some asset, a random thing. It's a traditional Windows box. Sure, I'm going to scan it. That's probably what I'm going to do. And I might say, yeah, look at that. I scanned it. There is, in fact, a missing patch. There's a vulnerability on that thing. Great. But if that's all I'm doing and that's all the information I have, what am I going to do with that? Well, I'll probably get around to patching it in a given month or whenever I can get around to it, because at this level, all vulnerabilities look the same. Well, what if I also add some context? What if I look at the user that's using that box? Maybe I find out that in my Active Directory setup on that laptop, it's used by someone named Jane Doe. And Jane is just a standard user within my AD structure, has no extra rights and privileges, no admin capabilities. Great. With that piece of context, I know that this laptop is just a standard user, no big deal. Sure, put it into the bucket for next month, just like my normal patch cycle, and I'm just going to go and let that rip. But this is adding a little bit of color. I've got some vulnerability management data, I've got some identity data, but that's not the only thing we're managing, right? We're managing cloud environments. Well, what if I'm looking at my cloud infrastructure? What if I'm looking at the application space that I have in my production environment in AWS? Well, if I'm looking at that, I might find out that, hey, actually Jane has an AWS account separate from AD. And that account has been given the administrator access role within AWS. That's root. That's full access to everything. So that means that this laptop, if that's compromised, if a criminal actor can get there, they can compromise those credentials. They can take over my entire production environment. Or even just an accident at this point. I might want to really rethink this a little bit about, does Jane need all of that access up there? Regardless, this extra piece of context, separate from everything else, this is going to change the decision I'm going to make. I may decide, like, this is way too important. If something were to compromise that laptop, our entire production environment could potentially be compromised. We need to solve this problem right now. Whether that's revoking access or whether it's just patching the laptop, whatever the problem or the right solutions for the business, we want to be able to do that. And this comes from being able to leverage all of these different pieces of security finding data. Again, if you normalize these findings, you understand the individual risks in context, you can start to connect the dots a little bit about what they mean to each other as well. And that sort of visibility gives us a more prioritized way of looking at, what do I fix first? What do I need to do to fix something first? Where am I going to best protect the organization, without trying to boil the ocean, without trying to do every single thing perfectly all at once? We want to get to this place where you've got that constant ongoing visibility about where you're at risk, and then identify the right ways and the right places to focus, so that you can meaningfully solve the problem. So that's a little bit of what we're doing at Tenable these days. Obviously, a lot more to it than that, but I wanted to just kind of walk you through, how this changes from a technical, purely operational exercise into something that's really about driving risk decisions, and really trying to help organizations get ahead of this game.
Yeah, I think that risk context is really important. You mentioned, because we see this in penetration testing. A lot of times, the access we get to an organization, if we're doing an internal pen test, especially if we've got access to something internally, like a compromised host or something we've placed there as part of the test, the pivots that we use to get full domain admin are often starting out as that lab box or that one Windows 11 machine, because that domain admin logged in there once and there's credentials there. So, contextually, if you use a traditional, like a CVSS, the CVSS base score doesn't consider context at all, but then the CVSS extended score only considers the raw context of the environment, meaning
Right.
lab box is a 1, period. So you're going to ignore it. But the reality of the risk environment in IT is more complicated than just it's a lab box, we can ignore it. And it's, if a domain admin logged in there and you can pivot to other assets, that's a really significant risk, even though it's that box a developer forgot about under his desk, So that's a good point.
Yeah, all those different findings. I mean, they're so critical in context with each other, right? I mean, we can talk about application vulnerabilities and code flaws, but then who has access to those repositories? Who has access to get to the code? Is that configured correctly? Even in really complex code or cloud environments, when you see shared repos and shared libraries all over the place, a very simple misconfiguration can turn those repositories into just fair game from any user in your environment, not just your dev team. And so, yeah, knowing all the pieces and how it connects, again, becomes really critical in that decision-making process of what's really the problem here, what's really the thing that I need to spend my time and resources trying to resolve, versus just trying to do it all, which is just going to burn everybody out if you're trying to do that. It's just not feasible. So yeah.
Awesome. I don't know if we had any questions. I don't think so.
So there is a Q&A tab, and if anybody has any questions, please type your questions in, and we will be able to answer them in the next few minutes. Something that I want to add personally from myself here is that obviously we think about vulnerabilities in many cases from perspective of risk, namely security risk, business risk. One of the things that we typically don't think when it comes to vulnerability management is your technical debt. But in many cases, vulnerabilities contribute to that technical debt. And the problem with this is even few vulnerabilities in a cloud environment, in your container, in your application, can turn your seemingly greenfield application into a brownfield application and prevent making this application modern in a few years' time. So that's something else that you may want to consider as part of your vulnerability management program. Like, how do I not only make sure that there are no security risks, operational risks, but how do I make sure that I don't leave behind any significant technical debt from the vulnerabilities that I decide to deprioritize and I decide not to fix at the time. So that's another thing that you may consider as you modernize your vulnerability management programs.